Hello guys, welcome back to my channel. So this is the continuation of the previous question. This is the first question basically. So we are going to discuss about this question. So yeah, question 1. So a set of 6 data. So a set of 6 data has a mean of 9. So I will jot it down. Has a mean of 9 and sum of square is sum of square is 1250, right? So sum of square, so I will denote it as x square. Okay, 1250, right? So if the number 7 is removed from the set of data, find the standard deviation. So then the standard deviation, we want to find sigma. Okay, from the mean formula, so mean is defined as the total sum of data divided by the number of data, which is 6, right? So this is 9. So sum of data is 9 times 6. 9 times 6 is 54. Why 6? Because we have a total of 6 data. Okay, 54, right? So we know that this is the sum, but we first want to find the sum, the new mean. Okay, the new mean. So the new mean, new, is sum of x new divided by the number of set of data, the new one. So the sum of data, so the new sum of data is 54 minus 7. Why? Because the number 7 is removed. Okay, the number 7 is removed, as you can see there. Number 7 is removed, so we minus from the total data, which is 54 minus 7, right? Divided by the number of data, the new one is 6 minus 1. Okay, because we exclude the 7 from the data set. Okay, so the new mean is 9.4, right? And then we want to find the new sum of square. The new sum of square, so previously it is 1250, right? But because we remove 7 from our data, so we minus with 7 square. Okay, because this sum of square is basically the data set which we square it individually. For example, if, okay, this is the example, right? So if we have, for example, 3 2 7 5 6 1, so this is only the example, and then the sum of data is basically 3 plus 2 plus 7 plus 5 plus 6 plus 1, right? But when we remove 7, okay, we just minus 7 from this data set, from this sum of x, right? So we minus 7. So that's why over here I minus 7. Okay, and then for sum of square is basically sum of square is 3 square plus 2 square plus 7 square plus 5 square plus 6 square plus 1 square. So if we remove 7 from the data set, which means we minus 7 square. Okay, because we are dealing with the sum of square. Okay, the sum of square, so we minus with 7 square. So that's why I wrote here 7 square, right? So 7 square is 49. Okay, which is 1201. So we have our new set of mean and also new sum of square. So we need to use our our standard deviation formula. So for standard deviation we have two formula, which is the sum of the sum of data, x minus the mu or the mean, we square and then we divide by the total value, the total number of data. Or this is also equivalent to the sum of square divided by the number of data minus the mean square, then we square root. Okay, so it is convenient to use the second formula. Why? Because we have the sum of square value over there, this one. Okay, so we can just use it. So sum of x square is, so we use the new one, alright, because why? Because we want to find the standard deviation of the remaining data. Okay, you need to read this: remaining data. Okay, remaining data, which means that after we remove this number 7, after we remove the number 7, so we need to use the new one. Alright, new one. So the new sum of square is 1201 divided by n. So the new number of data is 5. Alright, 5, because we remove 7. Okay, initially the number of data is 6 because we remove one of the data, so it left us with 5. Okay, 5, the number of data, minus the new mean. So the new mean is 9.4. We don't forget to square, and then we get approximately 12.32. Okay, so it's very simple. Alright, continue with question number B. So this is the diagram, shows the mass of watermelons produced by using two types of watermelon seed, type A and B, based on the mean mass. So we are dealing with mean again. Determine the type of watermelon seeds that produce heavier. So we want the heavier watermelon using appropriate digital software. So you can use any software, for example Excel, but for this purpose of the video I will use the manual calculation. Okay, so actually this is simple. First, you need to determine the midpoint of this, the class range. Okay, the class interval. So the midpoint of this is simple. In order to find the midpoint, is just plus the class limit and divide by 2, which is, see, so this is not minus. Alright, so this is not minus, so this is basically the interval range. Okay, so it's 1.1 kilogram until 1.5. Okay, so that's the meaning of the class limit or the class interval. So 1.5 plus 1.1 divided by 2 is basically on the middle of this number is basically 1.3. Okay, so it's 1.3. So this one is, you just add 0.2, so it's 1.8, isn't it? So add 0.2, 2.3, 2.8, sorry. Okay, 2.8. This is 3.3. That one is 3.8. Alright, okay, cool. And then after that, we just multiply this value. So we first we are dealing with the type A first, type A. So this is question B. So type A. So first is I multiply 3 with 1.3. Okay, 3 with 1.3. 3 times 1.3 plus, okay, another one is 10 times this. Okay, 10 times 1.8, 10 times 1.8 plus 7 times 2.3, 7 times 2.3 plus 5 times 2.8, 5 times 2.8 plus 3 times 3.3. Okay, 3 times 3.3. And then lastly is 2 times 3.8. 3 times 2 times 3.8. Okay, 2 times 3.8. 2 times 3.8. And then because we are looking for the mean is the total data set. Okay, we total the data set, we divide with the number of data set. So how many data set over here? So how many class limit? So if you look at this, so there are, so if you count from the first class limit, so from this 1 2 3 4 5 6, sorry, not the class limit, I mean how many the number of watermelon in total. Okay, sorry, not the class limit. Okay, sorry, my mistake. Okay, my bad. So how many watermelon over here? So you can just add up this 3, because this value 3 10 7 5 1 3 6 8 9 3 and so on is basically referring to the number of watermelons. So we need to divide with the total number of watermelon. So the total number of watermelon, if you calculate 3 times 3 plus 7 3 plus 10 plus 7 plus 5 plus 3 plus 2 is basically 30. This one is also the same, is 30 for type B, right? So you just adds up and you will get it's 30. So you just divide with the total number of watermelon, which is 30. Okay, and then you will get how much. So basically the top of the fraction, or the numerator, is basically the total. Okay, the total weight or the total mass of the watermelon. Okay, and then we need to divide by the number of watermelons so that we can get the average weight or the average mass of the watermelon for type A. Okay, so if you plug this into your calculator, eventually you will get the mean mass for A is 2.32 kilogram, right? And then you do the same thing for type B. So the mean for B is actually the same. Okay, the class limit is the same, right? So it cannot be different. So I will copy this. Okay, I just need to delete this, the number of watermelon for each given mass limit. I mean the mass, the class limit of the mass, right? So 1 3 6 8 9 3. Okay, so the mass is 1 3, okay, I forgot. 1 3 6 8 9 3 6 8 9 3. Okay, so the class limit is the same. The class limit is the same. You just multiply this, multiply with that 1.3, this with that, this with that, and so on until the last class limit. Alright, you will eventually get what, approximately, you plug this into your calculator, you will get about 2.80 kilogram. Okay, so you see that the mean mass of the watermelon B is slightly greater than mean mass of watermelon A, because 2.8 is of course bigger than 2.32 kilogram. Okay, so determine the type of watermelon. So we need to choose the heavier watermelon seed, which is seed B. Okay, seed type B. Why? Because of this justification, which I have been written on above, right? Over there. Okay, right. So next question is the question C. So the mark in the biology test of a group of 18 students are recorded. Okay. First you need to, okay, question 1, to represent the data in a stem and leaf diagram. So stem and leaf diagram is like this. So you need to remember that stem and leaf diagram is like this. Okay, so you have like a table, but you have just two columns. So this column is stem and this column is for the leaf. Stem and leaf, right? So for the stem, so my tips is you need to determine the smallest value first, from the smallest to the biggest. Okay, which is in ascending order. Okay, from smallest to the biggest value. So the smallest value is basically 21, right? So 21. So I will write the 2 in the stem part and the 1 is in the leaf part, like that. Okay, so this is the unit digit tens, and this leaf is unit digit ones. Okay, like that. What else? Okay, 21, after 21 we have in order is 24. Okay, 24 over there, right? 24, then we have 27. Okay, I will do 24 first. So we already have 2 over there. We just write 4 in the leaf part. Okay, so this is same like, okay, wait, let me finish in the 2 part first. So 24, what else? 27, 20 what, 28. We have 3 28s, right? So 28 over there. Okay, and also lastly is 29. Okay, so what we have, 27, 28. So 28 we have 8 times. So sorry, 28 we have 3 times. So 8, 8, 8, and then the last one is 29. So just write the 9 over there. Okay, so we have done the stem of 2. Okay, the stem of for the 2 for the 2. Okay, for the 2 of the tens digit. Okay, and for the trees, what about for the trees? So 3 we have so much. So 30, I will use different color maybe. 30, 31 we have 2, and then we have 32, we have 2 of them. Okay, 32, and then we have 33, and then we have 35, we have 2 of them, 35. Then 36 we have only 2. Okay, in the 3 part, in the digit of 3 in the stem part, okay, we have 30 what, 30, 31, we have 2 31s, we have 32, 2, okay, 2 digits of 32, and then we have 33 once, we have 35 twice. So okay, 35 twice, and then 36 twice also. So we have 2 6. Okay, we have 2 digits of 6 in the leaf part. Okay, like that. So we have done, and then the last one is for the digits of 4. Okay, 4. So we have 40. Okay, we have 40. Only one. Okay, only one, 40. So 40 like that, and then we are done like that. Okay, that's very simple. Okay, so find the interquartile range. Okay, so interquartile range is interquartile range, IQR, interquartile range is given by the third quartile minus the first quartile. Okay, so the third quartile, so because we have 18 number of data, okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18, so 18 number of data, n equals to 18, n equals to 18, okay, data. So first we need to determine our median. Okay, our median is located at the middle of the data, which is 18 divided by 2. Okay, so median is basically 18 divided by 2 plus 18 divided by 2 plus 18 divided by 2 plus 1 divided by 2. So this is our median. So 18th digit is basically, so 18th divided by 2 is basically, so let me correct my way of writing. So this is like that. So 18 divided by 2 is 9th. So in the 9th position plus the 10th position divided by 2. So in the 9th position is basically, so first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 31, right? 31. Okay, 31. Okay, 31 plus 31 over 2 is 31. Okay, so our median is 31 basically. So let me just erase this 31. So as long as we know that our median is 31. Okay, our third quartile is located at, first the third quartile is the 3/4 of the data times with 18th. Okay, so this is where is my calculator? So it is 13.5. So we just round it off to be 14th position. So in the 14th position is, so this is 9th, 10th, 11th, 12th, 13th, 14th, 35. Okay, 35. So it is our third quartile is 35, and our first quartile is just the quarter of the data, which position at 18 divided by 4, 4.5, in the 5th position. So the data in the 5th position is basically 1 2 3 4 5 28, right? 28. So we know our Q3 and Q1, so interquartile range is Q3 minus Q1, which is Q3 is 35 minus 28, which is 7th. Okay, 7th. Okay. Okay, so we find all of our quartile, first quartile, second quartile, which is the median, and then the third quartile. Okay. Okay, next and the last one is draw box and whisker plot. So box and whisker plot, the last one. So whisker plot, so the whisker plot is like a graph, so you just provide the graph like this. So my units, I will start from 10, okay, 15, 20, 25, 30, 35 and 40 is our maximum data. I will just sketch until 45. Okay, and then just determine our Q1. So Q1 is over here is 28. 28 is about here, right? So I will 25, 26, 7, 28. 28 is in the middle, like this. And then so this is our Q1. And then our median. So our median is Q2 is 31. 31 I will draw it to be like here. 31. Okay, 31 I will connect it like this. So this is our Q2. Okay, Q2, Q1 and Q2. And then our third quartile is 35, alright? 35 is over here. So it's precise there. 31 is there. 28 is there. Okay, so this is 28, 31, and this is 35, right? And then our tail, our left tail is the minimum value. So the minimum value from our stem and leaf sketch is 21. Okay, so this is the minimum value, 21. So 21 is about here, and then this is the tail. Oops, the tail. So 21 is there, and then our right tail is the maximum data set, which is 40. Okay, 40. So it's about here. Okay, so this is our whisker plot. Okay, box and whisker plot. And then we need to comment on the skewness. So skewness is basically, we have three type of skewness. The first one is when we have the tail is longer to the left, which is, so longer to the left is, wait, let me draw like this maybe. Okay, so it is longer to the left. Okay, longer to the left. So this is skew to the left. To the left, because the tail is longer to the left. Okay, and then for the second type of skewness is skew to the right. Okay, because this is skew to the right. Why? Because the tail over here is longer on the right side. And the last type of skewness is neither skew to the left nor skew to the right, because this is, we call this is the normal distribution, or what we call, okay, so it is called normal or bell curve distribution. So it has no skewness. Okay, the skewness is 0 because it is symmetric on the left and also right side. Okay, so for our case, we want to find, is it symmetrical, is it longer tail to the left or longer tail to the right. So for that purpose, we need to find the length. Okay, the length from the median to here, and also the length from the median to the maximum value, so that we can find the right tail. Okay, so for that purpose, let's check Q2 minus the minimum value on the left is 21. Okay, so Q2 is the median. So median is 31, right? 31 minus 21 is 10. Okay, so I want to check what is the length of the tail over here. Okay, so it is 10. Okay, and then on the right hand side I want to check the tail on the right, which is Q3 minus 40 minus Q3. So 40 minus, not Q3, sorry, not Q3, it's Q2. 40 minus 31, which is 9. So I know that the tail from the median to the maximum value in the data set is 9. So this is 10. So which part is longer, on the left or on the right side? So because the tail on the left is basically has 10 10 differences in numerical, which means that the differences between the minimum and also the median is 10. So it is longer to the left side, okay, than to the right side, which only consists of 9 differences in the difference in the numerical value. So I can say that it is longer to the left, like this. So it is what, skewed to the left, right? Because it is longer to the right, to the left side, right? So it is skew to the left. Why? Because the left tail is longer than right tail. Okay, so I think that is all for this video. Oops. Thank you, and I hope you understand my explanation, and good luck.